The ancient Greeks believed that there were only four elements that everything was made up of: earth, air, water, and fire. This theory was suggested around 450 BC and was the foundation of philosophy, science, and medicine for 2000 years. It was a simple theory based purely on the observation of the world at that time. But unfortunately, it failed to provide any measurable evidence and so had to be re-evaluated. It wasn't until the 5th century BC when Leucippus of Miletus developed the theory of atomism. He believed that everything in the universe was made up of tiny, indivisible blocks called atoms. After centuries of research, scientists can confirm that an atom is indeed the smallest particle of an element that has the same chemical properties as the original element. However, it turns out that atoms can be broken down further into many other subatomic particles. Furthermore, all the matter that is made up of atoms in the universe only amounts to about 5% of all the stuff that there is. So what makes up the rest of the 95% of the universe? Currently, scientists call this the dark universe, made up of dark matter and dark energy. No one really knows what dark matter and dark energy are or how they work, but there are many clues in the universe that point to their existence and may shed some light on what they might be. Let's take a closer look at exactly how we know the existence of dark matter and dark energy. But for the purpose of this video, we will only be focusing on dark matter and what we know about it so far. But as always, be sure to subscribe to our channel for more content ahead. When we look at something and are able to see it, we are looking at the assembly of the atoms structured in a particular way. The reason we are able to see anything is because light bounces off the atoms and reaches our eyes. This is true of all things composed of atoms in the universe. When scientists first started to study the motion of galaxies and measured the amount of visible matter they contain, some things just didn't add up. They noticed that the gravitational force needed to form large structures like our galaxy was too strong for the visible matter to produce by itself. So if the galaxies were dependent only on the gravitational force of the visible matter, they simply wouldn't be able to form. So all the stars and other material would just disperse throughout the universe. Repeated measurements all came up with similar results, indicating that there just wasn't enough visible matter to provide enough gravity to hold the galaxies together. And yet, galaxies are everywhere in the universe. So what is going on? Scientists figured that since galaxies do exist, despite the fact that there isn't enough visible matter to hold them together, there must be some kind of invisible matter all around them that is responsible for this extra gravity needed to form these structures. Since no light is emitted or reflected off of this mysterious matter, it was named dark matter. Scientists estimate that our universe contains about 27% of this dark matter, which does not directly interact with normal matter or the electromagnetic forces. So it is very hard to detect. But there are many clues that guarantee its existence. One such clue that points to the existence of dark matter is a phenomenon called gravitational lensing. Although we cannot directly observe dark matter, we can detect its influence by observing how the gravity of massive galaxy clusters with a heavy concentration of dark matter bends and distorts the light of more distant galaxies located behind these clusters. This shows that there is something there that interacts with gravity. Recent studies from the cosmic microwave background revealed that our early universe simply wouldn't be able to support matter clumping together if dark matter wasn't present from the start. Calculations show that it would require at least 1 million times the mass of our Sun in a particular region of space for the formation of stars to be possible. Many computer simulations point to how the early universe would be completely different without dark matter to allow the clumping of matter to take place. So there has to be something that contributes to the formation of these large structures in the universe. One theory in quantum mechanics known as supersymmetry promises to reveal what dark matter is. If true, it will predict a range of new particles, some of which make up dark matter. But until we have proof of supersymmetry, we are still in the dark. So far then, we do not have a clue as to what dark matter is. But we do know what it is not. For example, we know that dark matter is not a giant cloud of normal matter, since all normal matter interacts with light, so we can easily detect it by looking at it. Dark matter is also not the same as black holes, which are extremely dense objects that interact with their surroundings in violent ways. Furthermore, dark matter is not antimatter, because if it was, then there would be constant explosions everywhere, since matter and antimatter annihilate each other, producing unique gamma rays in the process. So far, we only know for sure that there's something out there that interacts with gravity and is spread throughout the visible universe, making up about 27% of it. And that is all we know about dark matter so far. Let us know down in the comments what you think dark matter could be. Also, if you enjoyed this video, make sure to give it a thumbs up, share with your family and friends, and subscribe to our channel. Until then, we'll see you in the next one.